Alright, so I'm going to go over a quick lesson on how to calculate gradient. Okay, we'll use this worksheet to help us learn what that is, take notes on that, and then have a document that we can kind of go back to as a example. You should have already learned about profile diagrams, which again basically is like the side view of a topographic map. So this would be like the bird's eye view or the top. This is the side view. Okay, now today what we're going to learn about is actually how to figure out the steepness of the slope simply by calculating gradient is what it's called. And so, you know, we can go ahead and create this profile diagram to see that from here to here, okay, is much steeper than it is from here to here. Now, we're going to skip that whole process. Using gradient, we'll be able to calculate it mathematically. Okay, so I guess to start off, I'm going to go up here and I'm going to give you guys the simplified definition of gradient. Okay, and gradient essentially is the steepness of a slope. Okay, so the higher the gradient, the higher the slope. The steeper the slope, the higher the gradient. Okay, our equation for this, okay, is essentially the same as the equation for slope in math, or m in y equals mx plus b, which is rise over run. Okay, so gradient is rise over run. Now also, and I think more simplified for our purposes, is actually going to be the change in elevation. That's always our rise. Okay, so if I go from point A to Cottonwood Creek, I'm at 580 feet above sea level, and then when I get down to Cottonwood Creek, it looks like I'm at 500. So my rise, or my change in elevation, would be 80 feet. So we're going to call our rise change in elevation. Okay, that number divided by our run, which is our horizontal distance from A to the creek. Okay, okay, horizontal displacement is what we'll call it. So I'm going to go ahead and give you guys a couple sample calculations. Over here, I'm going to go ahead and I'm going to calculate the gradient from point A to B. Okay, actually, excuse me, we're going to go from A to the creek. Okay, and so we're going to go from this point here to our creek. Now I know gradient is rise over run, or change in elevation over horizontal displacement. So gradient is going to be equal to my change in elevation, and at point B, the closest line I have is 580. So we're going to call this point B 580. Now I go down, and as it looks, contour interval is 20 meters, so I'm going down 580, 560, 540, 520, 500, and the creek bed is below that yet. Let's call the creek bed 500 though, because that's the last line we had. Okay, so my change in elevation is going to be 580 minus 500, okay, over my horizontal distance. Now the horizontal distance that we need to calculate, kind of tricky to do. You're going to need a piece of scrap paper, and you're going to need to make a measurement, because we want to know what the horizontal distance is from here to here, but we don't have any numbers. Okay, but we do have a map scale down below, and we're going to use that to calculate that distance. So I'm going to go ahead and put my post-it note just like this, so that the edge is at the 0, and then we're right here. So here's 0, here's 1, here's 2, and it looks like that's in kilometers. Okay, so that must mean that this is in meters. So I'm going to go ahead then and say, okay, well, from 580, or from point A on down to the creek, that's around, you know, here's like 1.5. We'll call it 1.4. Okay, so we're going to call that 1.4 kilometers. Okay, now you may actually need to use a calculator for this, because these numbers are going to be decimal points. So our gradient here, 580 minus 500, is going to be 80 meters over 1.4 kilometers. Okay, I'm going to go ahead and crunch that right now. Low on batteries. 80 divided by 1.4 gives me 57.14. And that's going to be meters in elevation per kilometers of distance we walk. Okay, that's the gradient from A to the creek. I'm going to have you go ahead and try this. Let's call it from B to the creek, okay? You go ahead and practice that, and I will have a solution for you in just a second. So why don't you go ahead and hit pause so you can use this as practice. Hit pause. Don't cheat. Hit pause. Okay, so here's your solution to B to the creek. So I measured 580 again because the closest line we have is 580, okay? The creek again, we named 500, so we're going to call that 500 over here. And that's all over 1.2 meters. Again, I took my measurement, I approximated. Again, we're not using the best tools here, so that's an approximation, but I would say that's about 1.2. So I took 1.2 kilometers, did the math, and it came out to be 66.67 meters per kilometer. Now we can actually take a look at this and say, okay, so obviously this is a larger number, this is a larger gradient. That means that the larger gradient says that I'm going up a steeper slope if I go from here to here. Okay. Or if I'm walking down the slope, I'm walking down a steeper slope. Okay. Either way, that's gradient. Now, I want one more practice one for you guys. Let's go from, let's say from here on down to point B. And we'll say point B is 400. We'll call this feet since we're in miles on the scale. Okay. You're going to need to use this scale to figure out the distances. Go ahead and hit pause. I'll work through this and come up with a solution, but for right now I want you to hit pause so you have some practice. Hit pause. And here's your solution. So if you walk from B to A, or B to this point, or from this point down to B, okay, the gradient would be 160 feet per mile. Again, we used 520 because this is a contour interval of 20, so this point's 520. Down here is 400. 520 minus 400 is 120. So that's the change in elevation. The change in displacement is going to be 0.75 miles. Now again, I used this little half mile to create my own scale. So what I did was I marked off 1/2, slid it down. There's 1 mile, slid it down 1.5, not knowing how much I'd need. And I lined it up, took a look, and that, again, to my roughest estimation, is probably close to the middle. So we call that 0.75 miles. And 120 divided by 0.75 is 160, which means that for every mile we walk on this gradient, we are increasing or decreasing our height by 160 feet. That's a short mini lesson on calculating gradient. Again, here is your explanation of it and a couple examples to take a look at. Hopefully this helps. Email, questions, I have your answers.